let's go ahead and take a look at the idea of higher order derivatives. In this example, we're going to take a second derivative. So I have this function, and I already found that the first derivative, y prime, was equal to negative x over y through implicit differentiation. Now I want to find the second derivative with respect to x. So I need to implicitly differentiate this again. So when I do, I'll get y double prime is equal to, now this is the quotient rule. Now remember, y is an implicit function of x. So the derivative of negative x is negative 1, so I have a negative y minus negative x times the derivative of y, which is y prime, divided by y squared. That is nothing more than an application of the quotient rule with implicit differentiation. Well, I'm going to rewrite this quickly. I'm going to make this a negative y plus x y prime over y squared. And the question now is this how we want to leave it, or do we need to modify it? And the answer is, well, we need to modify it a little bit. So I'm going to write it one more time. Y double prime equals negative y plus x y prime over y squared. Now the point here is that we know what y prime is. This is y prime. So I need to substitute that in. So this is going to be negative y plus x times negative x over y, because this is y prime right there, divided by y squared. So this will be, if I factor out these negatives, it would be a negative of y plus x squared over y squared, which of course you can do a little bit of simplification with. This would be a negative y over y squared plus x squared over y cubed, and of course that'll cancel, and I'll have a negative of 1 over y plus x squared over y cubed. I don't know, you keep fiddling with it if you want, but to me that's kind of like far enough. No, actually, no, I think I do want to go a little bit farther. Let's just go ahead and do this operation here, this addition operation here, because I just spotted something I was fiddling with this. So when I do this, I need to multiply this side by y squared over y squared to get y cubed. And on the numerator, I will now have a negative y squared plus x squared over, this will now give me y cubed in the denominator, which is fine and dandy, but if you remember, x squared plus y squared is 9. So this is actually equal to a negative 9 over y cubed. So this was an instance we're going a couple more steps rather than stopping there. Going just a couple more steps really nicely reduce this. So this is really nice and easy to work with now. So this would be the second derivative, and notice the second derivative only requires y. So if I know the y coordinate that I'm talking about, I can tell you the value of the second derivative. Now, we haven't exactly gotten to the importance of the second derivative yet, but we will. We will pretty soon, and you'll see how that makes perfect sense here in the future, not too far off.